Okay, here's the next section in lesson 2 that I want to talk about. If a question asks you to solve the triangle, what that means, if the question says solve this triangle, like triangle XYZ, that's this triangle, XYZ. Can you see my pen when I mark those? XYZ, I hope so. It wants us to solve for all missing sides and angles. So everything that I don't know. So when I go to triangle XYZ, I know this side length is 6 centimeters. This side length is 10. I don't know what this side length is. I'm going to call it side length Y. Let me write that out again. I'm going to call it side length lowercase y because it's across from angle Y. Okay. Speaking of which, because it's a 90-degree angle, what side length of the right angle triangle is this? Well, lowercase y is the hypotenuse. Okay. So I'm going to solve for that side length. I also, though, need to solve for all missing angles. So I'm going to solve for angle, let me get my pen again. I'm going to solve for angle Z here. And I'm going to solve for angle X. Now, we're going to have to use some trigonometry to do this. The first step, you might recognize a way to solve for y here is using Pythagorean theorem. So we could use Pythag to solve for y because I know two side lengths of this right angle triangle. And I'm looking for the hypotenuse, so I'm going to use the version of Pythag that is a squared plus b squared equals c squared. If I knew the hypotenuse, but I didn't know one of the legs, so like this 10 or this 6, I would use the version that was a squared. Sorry, let me try that again. I would use the version of Pythag that would be c squared minus a squared equals b squared. But we're not using that one in this case because we're trying to find the hypotenuse. So I'm going to plug in the numbers. 10 squared plus 6 squared equals c squared. Okay, so I'm going to get 100 plus 36 equals c squared. I have 136 equals c squared. And now I'm going to find c, to get c alone, the algebra says I have to take the square root of both sides. And so what is the square root of 136? Well, it's 11.66 and change. 11.66 and change. That equals c. So my hypotenuse, I labeled it c here because in the Pythagorean theorem it was c, but it's also y. Here, the hypotenuse is 11.66 and change centimeters long. Now, you're going to have to hold on to that number. If you think back a long time ago when we were in class and I told you about rounding, you need to keep at least 5 digits for that number or store that number in your calculator somehow. So it's 11.661903 ... So I'm going to just keep that number in mind if I'm going to use it in a calculation, okay? So I found y. Now I need to solve for the angles. So let's take a look and try and solve for angle Z here. Okay, I've got it in red. So angle Z, that's just a way of saying how to get angle Z. Think about SOHCAHTOA. If I want to find this angle, let's call it theta. I want to find that angle. What side lengths was I given? What side lengths was I given? I was given 6, which ends up being the opposite to that angle. And I was given 10, which ends up being the adjacent to that angle. So if I have the opposite and the adjacent, I'm going to use TOA. I'm going to use tan. So to find angle Z, I'm going to go tan of theta equals the opposite, which is 6, divided by the adjacent, which is 10. I hope this is becoming a little bit more clear as we do more examples. Like it's kind of always the same thing. You have to determine whether you're going to use sine, cos, or tan. You have to determine which side lengths you have of the triangle and then plug the numbers in. And now, again, in this case, because I'm looking for theta, I'm going to go the tan negative 1, or the second function tan of 6 over 10. So in your calculator, theta will equal second function tan 6 divided by 10, close the bracket. And so the angle there is 30.96 and change degrees. If we wanted to round it, we could round it to 31 degrees. But the question doesn't state round. It doesn't really matter in this case. So that angle Z, the red one, angle theta here, angle Z, is 31 degrees. Now, we can do the same process to find the other angle, because we need to find all of the angles and all of the side lengths in this triangle, right? That's what the question asked us to do. Just getting rid of some of that ink there. So now if I want to find angle X, this angle right here, angle X is in the kind of orangey yellow. Let's just call it theta now. I need to determine whether I'm going to use sine, cos, or tan. What do I have? What side lengths do I have? Well, if I'm using this angle theta, the opposite to angle theta is 10, and the adjacent to angle theta is 6. Do you see how that changed from the original angle Z? The opposite and the adjacent were flipped. It's because we're talking about a different angle now. So to find angle X, I'm going to, because I have the opposite and the adjacent, I'm going to use tan again. The tan of theta will equal the opposite, which is 10, over the adjacent, which is 6. And I'm going to go through the same process to find theta alone. I take the second function tan of 10 over 6. And theta will get me, if I go second function tan of 10 over 6, 59.03. 59.03 and change. So if I wanted to round it, 59 degrees. Now, I'm going to ask you a question to go back on your knowledge of, your previous knowledge of triangles here. Does the answer of 59 degrees for X and 31 degrees for Z make sense? Does that make sense? Well, I'm going to prove to you that yes, it does make sense. The question is, what is the sum of all angles in a triangle? In other words, if I were to take X and Z and Y and add them together, what should I get? Well, I should get 180 degrees. That's a 0. I promise that's a 0, but I don't actually like it, so I'm going to erase it. I should get 180 degrees. So let's see if we do. I know angle Y is 90 degrees. That's this angle right here. That's my squared angle. That's 90 degrees. I know angle Z we found to be 31 degrees, and angle X we found to be 59 degrees. When I add those together, do I get 180? Well, 31 plus 59 gets me 90, and 90 plus 90 is 180. Boom! We did it right. So we found those angles and the side length. We solved the triangle. I'll do another example for you, but I hope that makes sense.